Hello. Good evening, students. How are you all? My name is Kanika, your mathematics teacher. So today we are going to start with pair of linear equations in two variables. And in the previous class we had completed polynomials, and before that we had completed real numbers. So this is the third chapter, that is pair of linear equations in two variables from grade 10. Now this linear equations, I have already, just give me a minute. I think there's some technical issue. Maybe there's some internet issue. Give me 1 minute. So linear equations we have started in grade 7 and 8, where we were dealing with just one variable. We were dealing with one variable, that is x. X, that means only one variable, one unknown quantity where we were dealing with. Now, in grade 9, we dealt with linear equation in two variables, where we were dealing with two unknown quantities, where we took x and y. And this linear equation in two variables, which we were dealing in grade 9, we were actually dealing with a single equation. We were just dealing with one equation where there were two variables, two unknown quantities and one equation. So from that, we had I hope, am I audible to you, children? Just give me 1 minute. I'll just check. There's some internet issue. Give me 1 minute. Okay, so now in grade 10 we are going to start with pair of linear equation in two variables, where we will be dealing with two unknown quantities and two equations. In grade 9 we were dealing with one equation and two unknown quantities. Here we will be dealing with two unknown quantities and two equations. That's why it's pair of linear equation in two variables. So let us start with the class. So I'm going to first give you an example here. So we have Akhila. She went to a fair in her village. So just see, there's a nice fair and it's a village. Now she wanted to enjoy rides on the giant wheel and played hoopla, a game in which you throw a ring on the items in the stall, and if the ring covers any object completely, you get it. I hope you've already played this game hoopla, when you put the rings, and when the ring completely covers a particular object, then you win that object. Also, we have giant field. Giant field you must have enjoyed when you were young. Yes, we still enjoy giant field here. Okay, so now the number of times she played hoopla is half the number of times she had on the giant wheel. So multiple times she took ride on giant wheel, and she also played hoopla multiple times. That means more than once. Now we don't know how many times she has played hoopla. We also don't know how many times she has enjoyed giant wheel. But then we know that the cost of each ride, that means I'm referring to her giant wheel, the cost of the giant wheel ride is 3 rupees. So for once, if she enjoys a ride, she's going to pay 3 rupees. And a game of hoopla cost 4 rupees. So if she plays hoopla for the first time, she's going to pay 4 rupees. Every time she's going to pay 4 rupees. Now, how would you find out the number of times she had and how many times she played hoopla? Now we know the cost of each ride, that's 3 rupees. We also know the cost of game, that is 4 rupees. And we also know that she has 20 rupees. It is already given to us how many times she played hoopla, provided she spends 20 rupees. So in all, she's spending 20 rupees in the village fair. 3 rupees is the cost for the giant wheel, and 4 rupees is the cost for hoopla. Now we have to figure out how many times she has played hoopla and how many times she has enjoyed the ride. It is already given to us in the question that number of times she played hoopla is half the number of rides she had on the giant wheel. So keeping this in mind, we are going to first denote the number of times Akhila takes rides by X. So number of rides she has taken, we are going to denote it by X. And the number of times she played hoopla, we'll denote it by Y. Now we know that the number of times she played hoopla is y, and that is half the number of times she has enjoyed the rides. So we can say that y is half of x. This is one relation which we have got between x and y. Also, we know that 3 rupees is the cost for the ride. So if 3 rupees is the cost for the ride and she enjoys the ride for x times, she is going to pay 3x rupees. In the same way, 4 rupees is the cost for hoopla and she enjoys the game y number of times, so she is going to pay 4y. We also know that in all she has 20 rupees. So I'm going to add this and I'll get here 20. I'm going to add this and I'm going to get here 20. So this is another relation between x and y. Okay. Now children, we know that the number of times she played hoopla is half the number of times she has enjoyed the rides. So this is one relation between x and y. And this is another relation between x and y, keeping the cost of the game and the ride in mind. Here we have two equations and two unknown quantities. So we'll be finding these two unknown quantities in this chapter. So in this chapter, we are going to learn how to solve a pair of linear equations in two variables. Now a linear equation can be put in the form of ax plus by plus c equal to 0. So this we have already studied. We've already studied this in grade 9. In English, we have a format for writing a particular letter, or otherwise we have some format for writing message or for note making. In the same way, we have a format for writing a linear equation in two variables, that is ax plus by plus c is equal to 0. So that is how we ideally represent a linear equation in two variables. So we have first the x term, then y term, and then constant. Where a, b, c, they are all real numbers, and a and b are not both 0. So a and b are not both 0. If both of them become 0, what will happen? This will disappear and we'll be left with a constant equal to 0. So it will not be a linear equation. Even if I have a constant as 5, I'll get 5 is equal to 0. That's not true. So we often denote a and b not both 0 by a square plus b square not equal to 0. So this, children, you have started in grade 9 also. Now coming to solution of an equation. All this also we've done in grade 9. Solution of an equation. What do we mean by solution of an equation? Now a solution of a linear equation in two variables is a pair of values, one for x and the other for y, which makes the two sides of the equations equal. For example, let us put x equal to 1 and y equal to 1. Now this actually means solution of an equation. For example, if I take this equation, this one, I've taken 2x plus 3y is equal to 5. The solution of the equation means that particular value of x and y which is going to make the equation true, which is going to make this left and the right hand side equal. For example, if I am putting x as 1 and y as 1, both 1 and 1, so we are going to get 2 into 1 plus 3 into 1. That is 2 plus 3, that's 5. It is same as the right hand side. So actually x equal to 1 and y equal to 1 is making the equation true, is actually making LHS and RHS equal. So we can say x equal to 1 and y equal to 1 is solution of the given equation. Now let us put some different values of x and y. Let us put x equal to 1 and y equal to 7 in the same equation. So we are going to get 2 into 1 plus 3 into 7, that is 2 plus 21. This 3 into 7 will give us 21. 2 into 1 will give us 2. So this 2 plus 21 will give us 23. So it's 23. So actually I'm getting 23 here, but then I have 5 here. So they are not equal. LHS and RHS, they're not coming out to be equal when you put x 1 in place of x and 7 in place of y. So x equal to 1 and y equal to 7 is not a solution of the equation. It is not a solution of the equation. So solution of the equation means those values of x and y which are going to make the LHS and RHS true for an equation. Now in grade 9 when we dealt with a linear equation in two variables. A linear equation, that means only one linear equation in two variables. So if I take 2x plus 3y is equal to 5, that's a linear equation in two variables. And if I want solutions of the same, I'm going to get infinite solutions. I can just keep putting the values of x or y, any one term, one variable I can pick up, and accordingly I'll solve for the value of the other variable. So all this we've done in grade 9. So for a linear equation in two variables, it has infinite solutions. Now coming to the geometric meaning of solution. So what does this 1 is solution of 2x plus 3y is equal to 5 means geometrically? This means that actually when we take 2x plus 3y is equal to 5, we take this equation and we represent this on the Cartesian plane. On x and y axis, if we represent this, we are going to always get a straight line. You will always get a straight line when you draw graph of a linear equation in two variables on a Cartesian plane. And if you don't get a straight line, that means you made some mistake. So you will always get a straight line for a linear equation in two variables. Now 1 is solution of the equation means that this point 1 will lie on the line, will lie on the graph of the equation 2x plus 3y equal to 5. So if you draw the graph of 2x plus 3y equal to 5, if I say 1 is solution of the equation, you are going to find that point 1 on the line which represents 2x plus 3y equal to 5. And then just as I explained you, 1 is not solution of the equation. That means this 1 will lie somewhere outside the line. It will not lie on the line. On the line representing 2x plus 3y equal to 5. So every solution of the equation is a point on the line representing it. So whatever solutions you find out for a particular line, like in this case, for example, I have 2x plus 3y equal to 5. I draw a line for this. I'm going to draw a graph of this on a Cartesian plane. I'll get a line. All the solutions for this, as I just told you, there are infinite solutions for a linear equation in two variables. All the solutions, they're going to lie on the line. Each solution xy of a linear equation in two variables corresponds to a point on the line representing the equation and vice versa. So all the solutions, they're going to lie on the line 2x plus 3y equal to 5, and all the points, like it's vice versa also, all the points on 2x plus 3y equal to 5, that's line, all the points on the line, they would be solutions of the equation. So if I have an equation, all the solutions will lie on the line, and all the points on the line would be solution of the equation. So all this we've done in grade 9 also. Now let's proceed one step further, coming to grade 10 where we are dealing with pair of linear equation in two variables. Now two linear equation in two variables x and y are called pair of linear equation in two variables. In general form, a pair of linear equation in two variables x and y is a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 equal to 0. So these are pair of linear equations in two variables. So here we are dealing with two variables in x and y, and also we have two equations. Now we have examples of a pair of linear equation in two variables, like we have this and this, they form a pair of linear equation in two variables. We also have another example, 5x equal to y minus 7x plus 2y plus 3 equal to 0. Now the third example is x plus y equal to 7 and x minus y is equal to 1. Now students, we know that a linear equation in two variables, whenever you draw on a Cartesian plane, it will represent a straight line. Now what if you take a single Cartesian plane and you draw two linear equations? You draw graphs of two linear equations on that particular Cartesian plane. You're going to get two lines, right? One equation will represent one line, so two linear equations will give you two lines on the same Cartesian plane. Please notice I'm talking about the same Cartesian planes. So don't make two different graphs. Take only one graph sheet, make a Cartesian plane, and on that Cartesian plane, if you draw graphs of two linear equations in x and y both, then you're going to get two lines. Now if you get two lines, you will get the lines in three possible ways. So two lines in a plane, only one of the following three possibilities can happen. So you can get in any one of these three ways. You can either get intersecting lines, or the lines can be parallel, or we can say that the lines are coincident. That means they will be overlapping one on the other. So if we have two lines in a plane, they can either be intersecting lines, or they can be parallel line, or they can be coincident lines. Now I just told you for a solution of the equation. A solution of the equation means that that particular point, whatever, like if we have the values of x and y, they satisfy the equation, they're going to lie on graph of a linear equation in two variables. Now in this case, where we are dealing with two linear equations and two variables, we are looking for that point which is going to satisfy both the equations simultaneously. Please notice, I'm repeating myself, that if we are dealing with two linear equations in the same variables x and y, we are looking for those values of x and y which is going to satisfy both the equations simultaneously. Now, if that particular point satisfies both the equations simultaneously, that means that point will lie on graphs of both the equations. That is going to lie on graphs of both the equations. For examples, in this case, I've drawn graph of one equation and this is graph of the other one, let us say. So I have only this particular point which is common to both the lines here. So this particular point is solution of both the equations. So how many points do we have here? We have only one point in common. Since the lines are intersecting, we have only one point in common. So this is the case of unique solution. That means there is only one solution. There is only one pair of values of x and y which is going to satisfy both the equations simultaneously. That's the case of intersecting lines. When we have two lines cutting each other on a single Cartesian plane, they're going to intersect at one point. They will have only one point in common. That point in common is actually that value of x and y which satisfies both the equations simultaneously. This is the case of unique solution. So we say that the given pair of equations, they have unique solution. They have only one pair of of the values of x and y which satisfies both the equations simultaneously. Now let us discuss the next one here. When the lines are parallel, so please observe, let's say that these two lines, they are representing two linear equations and two variables. So how many points in common do we have? Do we have any point in common? They are parallel lines. Even if I extend these lines, they will never meet. They will never meet. That means they don't have any point in common. No point in common. That means there is no value of x and y which is going to satisfy both the equations simultaneously. So this is the case of no solution. This is the case of no solution. Now let's discuss the third case where the lines are coincident. So one on the other, the lines are overlapping. They're one on the other. In this case, just see how many points in common do we have? They're one on the other. So many points in common, isn't it? There are infinite number of points which are common to both the lines. So we can say that there are infinite points which satisfy both the equations simultaneously. So this is the case of infinite solutions. This is the case of infinite solutions. Now please notice, for a pair of linear equations and two variables, we have the first case where the lines are intersecting. In this case, we have only one point in common. So that's the case of unique solution. When the lines are parallel, we don't have any point in common. That's the case of no solution. Now in the third case, we have two lines. They're coincident lines. So that's the case of infinite solutions. Now please notice, for a pair of linear equations, if we have solution, whether the solutions are infinite or we have a unique solution, we say that the set of equations is consistent. Consistent means we have solution. Doesn't matter even if you have unique solution or infinite, but then if you have solution, you will say that the set of equations is consistent. That means in this case, we will say that the set of equations is consistent. And for infinite solution also, we have, for infinite solution also, we have the set of equations is consistent. Now what if the given set of equations doesn't have a solution? That means there is no particular value of x and y which is going to satisfy both the equations simultaneously. So that's the case of parallel lines where we don't have that's the case of parallel lines when we don't have any point in common. So this is the case of inconsistent. The set of equations is inconsistent in this case. So when the lines are intersecting, we have unique solution. The solution exists. We'll say that the set of equations is consistent. If the lines are coincident, they are overlapping each other, we have infinite solutions. Yes, we have solutions. Doesn't matter even if we have infinite solutions. We'll say that the set of equations is consistent. And in case of parallel lines, where there is no point in common, no particular value of x and y, which is going to satisfy both the equations simultaneously, that's the case of no solution. So we will say that the set of equations is inconsistent. Inconsistent. Now coming back to the Akhila's example which we were dealing with. Please give me 1 minute. Children, please give me 1 minute. It's taking time. Okay. Now coming back to this. So let us come back to the example which we were dealing with, the Akhila's example, where she went to a village and she played hoopla. She also enjoyed the giant wheel ride, and we were already having two equations here. So we were dealing with this x and y here. So let's come back to the example here now. Now we are going to represent this. Now she goes to a fair with 20 rupees and wants to have rides on the giant wheel and play hoopla. So this we've already discussed. We have to represent this situation algebraically and graphically. So algebraically we have already represented. We have represented this in the form of two equations in x and y. So if we have y is equal to half of x, just see how I'm writing this, how y is equal to half of x. So I'm going to take this 2 on the other side. I'll get 2y is equal to x. Then I will take this 2y on the right hand side. I'll get x minus 2y is equal to 0. So I've written equation y is equal to half of x as x minus 2y is equal to 0. And then this equation we had already formed earlier. Now we are going to represent this on a Cartesian plane. So before we do that, as you're going to do in the same way as you did in grade 9, you're going to make the table for these two equations. So we'll first make the table of x minus 2y equal to 0. Now when we make the table of x minus 2y equal to 0, we can pick up any variable, either x or y. We'll put values for it and then we'll get the corresponding values of y. So if we have x is, let's say if I put x is equal to 0, if I put 0 here, I'll get 0 minus 2y is equal to 0. So in that case, I'll get 0 as the value of y also. So 1 point we have got 0, 0. Now let's take this x as 2. So I have x minus 2y is equal to 0. If I put x as 2 here, I'm going to get 2 minus 2y is equal to 0. So I can just take here, in order to make this LHS and RHS equal, I'll get y as 1. So 2, 1 is another solution for this equation. Now I'll take the Cartesian plane and I'm going to plot these points. So let's see what we're going to plot points 0, 0 and 2, 1. So this is the graph which is already done. This 0, 0, we have taken this point, and 2, 1. 2, 1 is this one, this point. Now once we locate 2 points on the Cartesian plane, we can nicely draw a straight line passing through both of them. So for drawing a particular line for a linear equation, you need at least 2 points. You can take 3 also if you want, just to check whatever you are doing is correct. Because if the third one doesn't lie on the line, that means you can figure out that you made some mistake. So You take at least 2 points. If you want, you can take 3. So in this case, we have taken just 2 points. We have located them on the Cartesian plane, and then we have drawn a line passing through both of them. Same we are going to do for the other equation. So we have 3x plus 4y is equal to 20. So we have 3x plus 4y is equal to 20. You put x is equal to 0. If you put x is equal to 0, this term will disappear. So you will get 4y is equal to 20. Finally, you will get y as 5. So we have 0, 5 here. Let's take this one. Now, if you take x as 20 upon 3. If you take x as 20 upon 3, you're going to get 3 into 20 upon 3 plus 4y is equal to 20. And you will cancel out this, and then you will get y as 0. But it's difficult to locate 20 upon 3 on the Cartesian plane. So that's why I've taken another point. So I've taken here x as 4. So if we take x as 4, we'll get 4 into 3, that's 12. So we'll actually get 12 plus 4y is equal to 20. Now once we solve this, we're going to get y as 2. So this 4, 2 is another solution for this equation. Now we'll go back to the Cartesian plane, the same Cartesian plane, and we locate points 0, 5 and 4, 2. 0, 5. 0, 5 is this point. Please notice 0, 5. It has x coordinate 0. So this point is going to lie on y-axis. This we have studied in the coordinate geometry chapter in grade 9. Now 4, 2. 4, 2 is another point here. We have 4, 2. This is the point. Now we are going to draw a line here which is going to pass through these 2 points. Now as we can see that these 2 lines are intersecting, the point of intersection here is solution for the equation. So this is the point of intersection we have. That's 4, 2. This is solution for the set of equations we have. That means x equal to 4 and y equal to 2 will satisfy both the equations simultaneously. X equal to 4, y is equal to 2. So coming back to this, x equal to 4, y is equal to 2. So x, what did we take x as? We took x as the number of rides. So she took 4 rides. So we took here, coming back to the, where is it? Yes, this one. So this is x is equal to 4 and y is equal to 2. So we took the number of rides. Akhila had 4 and number of times she played hoopla is 2. So finally we can say that she took the she enjoyed the number of rides 4 times. She enjoyed the rides 4 times. She played hoopla 2 times. And in all she had spent 20 rupees. So this is satisfying this entire situation. Now please notice here in this particular graph, I want to show you one more thing. Now since we have the graph, it's intersecting. At times in the exam, you get questions like you get a word problem like we had this Akhila's problem, and you are asked to form the equation for the situation. You're also asked to draw a graph of the same on a single Cartesian plane. After that, there's one more question attached to it. At times we get questions like obtain the vertices of the triangle so formed with x-axis. I'm repeating this. You have to obtain the vertices of the triangle so formed with x-axis or y-axis also. Like in this case, we are getting a triangle here with the lines and the x-axis. So at times they ask us to give the vertices of the triangle. So you're going to give these vertices. You are going to give these vertices here. In the same way, you can be asked to give the vertices of the triangle formed by these 2 equations with y-axis. So this is y-axis we have, and we have this triangle, which we get, which we are going to get with these lines and y-axis. So at times you're asked to give the vertices here. So these are the vertices. You can give these coordinates. Also, at times in the exam, you're also asked to calculate the area of the triangle formed. Like in this case, for example, if I take this particular triangle, the triangle which is formed with these lines and a y-axis, how will you calculate the area? We know that we calculate the area using half into base into height. We use this. Now please notice here the base. This is the base, and let's take the corresponding height as this one. This is the corresponding height. Now since this is on the Cartesian plane, it's very easy to calculate the units. We can just count the units. So this is the base. We have 1, 2, 3, 4 and 5. So we know that the base is 5 units. And the height, we have the corresponding height as 1, 2, 3 and 4. So we have height as 4 units. So half into base into height, you can just count the blocks here, and then you can count. You can put them in the corresponding places, like in the case of base and height. So now we can calculate this, and we are going to get here 10 square units. So finally, the area of the triangle obtained by these two lines and y-axis is 10 square units. So you're going to get this from the Cartesian plane only, from the graph itself. I hope you've all understood this. Okay, so now let's proceed to the next one. Romila went to a stationery shop and purchased 2 pencils and 3 erasers for 9 rupees. So she went to a shop, she's purchased 2 pencils, we know this, she's purchased 3 erasers, and she spent 9 rupees and all. We don't know the price of pencil, we don't even know the price of eraser. 1 eraser, 1 pencil, we don't know the cost of it. Now she showed the same thing to her friend Sonali, and she was very excited to see that. And she also went to the same shop, and she had bought 4 pencils and 6 erasers of the same kind. Now her friend goes to the same shop. She has purchased now 4 pencils and 6 erasers of the same kind. Also it is given to us that she has spent 18 rupees. Now these are two situations where we know how many pencils and erasers have been purchased, how much total amount has been given to the shopkeeper in both the cases, in Romila's case and in Sonali's case. But something very important, we don't know the price of 1 pencil, we don't even know the price of eraser. So let us take X rupees as price of 1 pencil, Y rupees as price of 1 eraser. Now here we know in the first case, let's talk about Romila's case. Romila has purchased 2 pencils and 3 erasers. Now if she purchases 2 pencils and 3 erasers, we know 1 pencil is costing X rupees, so she's going to spend 2x rupees on pencils. Also she's going to spend 3y rupees on eraser. She's purchasing 3 erasers. 1 eraser is costing y rupees. Now in all, that means I'm adding here, in all she's spending 9 rupees. So we have got this equation, 2x plus 3y is equal to 9. So this is one equation we've got. Now let us discuss the next one, Sonali. Now X rupees she has spent on pencil. 1 pencil is costing X rupees. She has purchased 4 pencils. So she is spending 4x rupees on pencils. Y rupees is the price of 1 eraser, and she is purchasing 6 erasers in this case. So she is spending 6y rupees on erasers. In all, she is spending 18 rupees. This is given to us in the question. Now this is another equation we have got. We have got here 4x plus 6y is equal to 18. Now we have these two equations. We'll be dealing with the same. We have to represent this situation graphically. So we have to draw graphs of these two equations on the Cartesian plane. Now we'll do it in the same way as the previous question. We are going to make the table of 2x plus 3y is equal to 9. We'll put some values of x and y. Let's say if I put x is equal to 0, I'll get 2 into 0. So this will become 0. So I'll get 3y is equal to 9. 3y equal to 9 would be 3 only. We'll get y as 3. So we have 0, 3 as one solution. Let us put x as 4.5. If I put x as 4.5, I'll get 2 into 4.5 plus 3y is equal to 9. This will give you 9 plus 3y is equal to 9. This 9 and 9 will get cancelled. We'll get 3y is equal to 0. This will give us y is equal to 0. So finally we have 4.5, 0. That's another solution. So we are going to plot these points on the Cartesian plane, and we will nicely draw a line. Now once this is done, we'll come to the second equation, that is 4x plus 6y is equal to 18. So whatever values you take for x and y, that is your choice. It doesn't mean that you have to take the same values. You can take any values of your choice. Preferably take those values where you get integers so that it is easy for you to locate. So if we put x is equal to 0, you're going to get 0 here. 0 into 4 is 0. So you will get 6y is equal to 18. Finally, y is 3. So this 0, 3 is one coordinate which we are going to plot on the graph. You're going to plot on the same graph where you've already done this work. Now let's take x as 3. If you take x as 3, you will get 4 into 3 plus 6y is equal to 18. This will give you 12 plus 6y is equal to 18. And this will give you 6y is equal to 6. 12 will go on the other side. It will get subtracted. You will get 18 minus 12, that is 6. Now this is going to give you y is equal to 1. Y is 1 here. So that's another solution. We have 3, 1 here. We are going to take the points 0, 3 and 3, 1 and we are going to locate them on the same Cartesian plane where we have done all this work. So also we are going to join these points. So we'll join these points and this point. So I'll show you the complete solution here. Now please notice we have point 0, 3 here. This is the point 0, 3. Since the x coordinate is 0, this is going to lie on y-axis. Then we have 4.50. 4.50. So since the y coordinate is 0, it is going to lie on x-axis. Now once we locate these 2 points, we'll draw a line here. Now for the next one also we have point 0, 3. So that's the same point here, 0, 3. And then we have 3, 1. 3, 1. Now once we draw the 0, 3 and 3, 1, a line joining 0, 3 and 3, 1, we will get the same line actually. Just see, we're getting the same line. So we can say that the graphs of these two equations, they are coincident. They are completely overlapping each other. So we observe that both the lines coincide. This is so because both the equations are equivalent. They're actually the same equations. That is, one can be derived from the other. So as we are saying that the equations are equivalent, let us see. We have 2x plus 3y is equal to 9. Now please notice, if I multiply this entire thing by 2, I multiply both LHS and RHS by 2, what am I going to get? I'll get 4x plus 6y is equal to 18. So can I say that I've derived this one from this equation? The second one I've derived from the first one. If I multiply both LHS and RHS by 2, I'll get 4x plus 6y is equal to 18. So both the equations are equivalent. Now, please observe here. What if I take this equation and I divide this throughout by 2? I divide LHS and RHS by 2. I will get here 2x plus 3y equal to 9. 2x plus 3y is equal to 9. So can I say it's the same equation? Yes, it is. So I have actually derived this equation from this one. This equation I have derived from the second one. So that is why we are saying that this is so because both the equations, they are equivalent. That is, one can be derived from the other. So this is the case of infinite solutions where the lines, they are coincident. They coincide. I hope children you've all understood this. Now let us discuss the last one, the last case here. Okay, so all these questions which I'm discussing with you, they are given in the form of examples in NCERT. You will find the graphs, everything with the entire solutions in NCERT. Here we have two rays. They are represented by the equations x plus 2y minus 4 is equal to 0 and 2x plus 4y minus 12 is equal to 0. So we have two rails here. We have two rails here and then they are represented by the equations. The equations are given to you. You have to represent this situation geometrically. Geometrically means you have to do it on the graph sheet. You have to draw graphs of these two equations. So we'll follow the same process. We are going to create table of x here. So we are going to put here x is equal to 0. And once you put x is equal to 0, you will get 2y minus 4 is equal to 0. This will give you the value of y as 2. So you will get here 0, 2. Now if you put here x is equal to 4. So let's put here x is equal to 4. We'll get 4 plus 2y minus 4 is equal to 0. This will get cancelled and then we have 2y equal to 0. So y is 0. If we put x equal to 4, we are going to get y is equal to 0. So that's another solution of the equation. Now we'll take the Cartesian plane. We are going to plot the points 0, 2 and 4, 0 on it, and we'll neatly draw a line passing through both these points. Now we are done with the first equation. Let's come to the second one. We have 2x plus 4y minus 12 is equal to 0. We are going to put here x is equal to 0. As I just told you earlier, it doesn't mean every time you have to put x equal to 0 or something. You can take any number of your choice. Preferably take those values which are going to give you results as integers, because integers are easy to plot on the graph. Now x equal to 0, if we take, this will disappear. 2 into 0 is 0. So we can just ignore it, and then we will get 4y minus 12 is equal to 0. This will give us y equal to 3. So we have one solution here, 0, 3. In the same way, if I put x is equal y equal to 6, x equal to 6. I'm going to put x is equal to 6 here. I'll get 2 into 6 plus 4y minus 12 is equal to 0. This will give us 12. 12 plus 4y minus 12 is equal to 0. So we will cancel out this and we'll get 4y is equal to 0. We'll get here 0. So 6, 0 is another solution for this equation. Now we'll take the points 0, 3 and 6, 0. We are going to plot them on the Cartesian plane and we'll neatly draw a line passing through both of them. Let us see what do we get. Okay. Now this is the graph which we are getting. So coming back to this, 0, 2 and 4, 0. We have 0, 2 here. Then we have 4, 0 here. These are the solutions for the first equations. We have plotted these points and we have drawn a line passing through both of them. Coming to the second equation, we have 0, 3 and 6, 0. 0, 3 is here and then we have 6, 0 here. Now we are going to draw a line passing through both of them. Now please observe these two lines, they don't intersect anywhere. They are parallel. Even if you keep extending them, they will not meet. They are parallel lines. So this is the case of no solution. Okay children, so in today's class, we have discussed basically about the consistency of the equations. So what did we deal with? First, in the first step, we know what is solution of the equation. We've learned today what is solution of the equation. Those values of x and y which is going to satisfy the equation, which is going to make LHS and RHS equal. We also know that a linear equation in two variables, when we draw graph of the same on a Cartesian plane, we always get a straight line. Every solution will be a point on the line represented by the linear equation and vice versa. Vice versa means all the points lying on the line, they will be solutions of the equation. Now this is the standard form for writing a pair of linear equations in two variables. We have a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 equal to 0. Now if we draw two linear equations in two variables on a single Cartesian plane, the lines can either be intersecting or they are parallel, or we can have coincident lines. In case of intersecting lines, we have only one point in common. That's the case of unique solution. In case of coincident lines, we will have infinite points in common. Now, if we have solution for a set of linear equations in two variables, whether we have unique solution or infinite solution, that doesn't matter. But if we have solution, we will say that the set of equations is consistent. Consistent means that the solution exists. What if the lines are parallel? They have no point in common. That's the case of no solution. So for a set of equations to have no points in common on the Cartesian plane, we say that that's the case of no solution. So we will say that is the case of inconsistency. That means the set of equations is inconsistent, doesn't have a solution. And also in today's class, we have learned how to draw graphs of linear equations in two variables. So we have discussed the graph things in detail. In tomorrow's class, I'll be explaining you, I'll just show you that also. Now, a pair of linear equations in two variables can be represented and solved by the graphical method. So today we have learned the graphical method, how to figure out the solution of a set of linear equations through graphs, graphically. In tomorrow's class, we'll be learning algebraic methods. So I'm winding up here. For the timing, I've discussed graphical method. In tomorrow's class, we'll start with the algebraic method. So before you come for the tomorrow's class, please make sure that